So dear students, as we know, this is not mandatory. This is no any hard and fast rule that you only will be transmitting power through AC transmission line. As I told you, now there is a trend, and thanks to power electronics, thanks to thyristor, thanks to these power diode, now we are able to convert AC generated power into DC for long distance transmission line. So power could be transmitted by alternating or direct current systems, means AC or DC system, depending on the type of generation available. But again, this statement is not looks does not look feasible, because even though you have AC generation, you can convert that AC generated power into DC, and then you transport the power through DC transmission line. So the type of load for which power is needed by overhead lines or underground, as I told you, it is not again mandatory that you have only overhead transmission lines. So you can have either overhead transmission lines or purely underground system, or combination of both overhead and underground. So the combination or mix of overhead and underground is called hybrid transmission lines. So hybrid transmission lines composed of both overhead and underground system. So they have certain technical issues, but this is not our purview. Inshallah, we will discuss somewhere or sometime when we found it feasible. So overall, you have the power to be transmitted. Either you have AC transmission lines or DC transmission line. So you have options. If you are economically sound, your company is well established, your country is financially stable, so you can now no issue to transport and power through DC transmission line, because the cost of conversion and inversion is very high. What do we mean by conversion? Conversion means to convert AC power into DC, and inversion means converting again DC power back into AC for utilization and for use. So now we are clear that it is not mandatory that all the time we transmit power through only AC lines. So we have both options available, AC as well as DC. So if we count, if we discuss DC transmission line, then there might be certain good features of DC transmission line. So what are those? A DC transmission line needs only two conductors, hence line cost decreases. As we know that AC transmission line is three-phase, three-wire system, whereas in DC transmission line, irrespective of what is the volume of voltage, either it is 800 kV, 1000 kV, 500 kV, I am talking about DC transmission line, it always composed of only two conductors, whereas AC transmission line consists of three different phases. And again, when we will inshallah discuss this AC transmission system, we will consider that these are bundled conductors. So even we have a single phase but multiple conductors, that's called bundled conductor. So cost of spacing, damping, insulators, and the cost of material volume of conductor itself is very high in DC AC transmission line. So we have only two conductors in DC, so the cost is also reduced. So again we have a DC line has no reactance, and power factor does not come into the picture at all. So now number two is that DC line has no reactance, because you know inductive reactance is XL is equals to 2 pi FL. So since there is no frequency F is equals to 0 in DC transmission, so there will be no reactance. So when no reactance means the impedance is simply nothing but Z is equals to R, because when we are talking about impedance in AC power system, this Z is equals to under root R square plus XL square. So it means when you are using or transmitting power through DC transmission lines, no, the frequency does not exist. So your XL is equals to 0. So your impedance is reduced as compared to higher value of impedance in AC transmission line. Higher the impedance, higher will be the voltage drop. So dear student, number 3, when your impedance is reduced, the voltage drop is also reduced. So there is the issue of stability. Inshallah, I will share when I will be delivering my lecture through the board. So I will write those simplest equations so that you can understand. So DC voltages that could be generated are limited in magnitudes. Therefore, no need to transform the generated voltage to a higher one except one through motor current. हाँ यहाँ पे जो चीज़ है आप कहेंगे कि दो मुतजाद चीज़ें सर आप डिस्कस कर रहे हैं. एक तरफ आप कह रहे हैं कि ये टेक्निकली पॉसिबल है, दूसरी तरफ आप ये करें कि ये थोड़ा सा प्रैक्टिकल इम्पॉसिबल है. तो प्रैक्टिकल इम्पॉसिबिलिटी की जो पॉइंट है वो सिर्फ जनरेशन पॉइंट ऑफ व्यू से. इफ यू आर जनरेटिंग पावर थ्रू डीसी जनरेटर, then this is not technically possible to transmit that, because one thing that has the advantage of transformer. As we discussed in our previous subject of electrical machines, we are generating power at low voltages because of insulation and heating and cooling issues, and then we are boosting that voltage through the transformer to higher levels. So, but if you generate power through DC generators and then you transmit it through DC transmission line, then this is not technically possible. So the best solution is you generate power through AC generators, synchronous generators, and then you convert them into the DC through the power electronic controllers. So with the development of efficient power electronic devices, as I told you, like thyristor, IGBT, MOSFET, and power diodes, there is a trend again towards DC transmission, DC power transmission. So as to realize the advantage of AC generation and DC transmission. So dear students, this is the conclusion point, that this is technically, if the more technical advantages are to generate power through AC systems, and the most best recommended practice is to transmit the generated power through DC transmission line. Now I hope you are clear about. So if you sum up, if you summarize the advantage of DC transmission line, so you can say that we have a saving of conductor material. We have efficiency aspects in DC transmission line. We have very low voltage regulation issues in DC transmission line. This is actually why we are going now towards DC transmission.